The last kind of rate and distance problem we're likely to meet in a systems of linear equations context has to do with traveling up and downstream. So in this story, a boat travels upstream, that is, against the current, for 300 miles in 10 hours. Then it returns downstream with the current to its starting point. The return trip takes only 6 hours. And we'd like to know how fast is the current, and what is the boat's speed in still water. Right, so our unknowns are easy to spot. They're right in the question. But the rules are a little bit harder. Of course, we still have distance equals rate times time. But then there's this upstream, downstream stuff that asks us to draw on our background knowledge about the world. If we don't actually know that much about river travel or air travel, these are sometimes air travel, we might have to stop and think about this for a minute. So when we're going upstream, right, that means that while we're going this way, the river is going back this way underneath us. Right, so the river going in the opposite direction of us slows us down, right? It pulls us somewhat backwards. So the upstream speed is how fast we would be going without the current minus the current speed. Right, when we're going downstream, it's the opposite effect. It's how fast we would be going in still water plus how fast the water carries us. Right, now, if we didn't know these two facts about the world, this is something that we might consult an outside resource for. But we do know these two facts about the world now, and so I think that we're prepared to model this problem. Pause the video now and try writing down this model. There are two possible ways that you could do it, and either one is correct. I'll show you both of them once I start playing again. Okay. I promised you two possible models, and they both use the speed of the current. I'm just going to call these x and y because they're both speeds, and I don't feel like coming up with clever names for them. You, of course, could use whatever other letters you chose. All right, so for the upstream rule, there are two possible equations you could have written. You could have chosen to say that the distance I go upstream is the speed at which I go upstream, which is my speed in still water minus the current speed, times the time that I go upstream, which is 10 hours. Choice number 2 would be to just work with speeds. Right? If I go 300 miles in 10 hours, my speed is 300 divided by 10. And that'll be my speed in still water minus the speed in the current. Either one of these would be correct. I like this one better because my variables don't have coefficients. We can do the same thing for the downstream trip. We could either say distance equals speed times time, or just speed equals speed. And again, I'm going to choose to work with choice 2 when I solve this system because I think it's an easier system to solve. All right. Pause the video now and try solving this system. Okay, so my first step, I'm going to do this division, and I'll get 30 equals y minus x, and I'll get 50 equals y plus x. Now, this system wouldn't be too hard to do substitution with, but I think it'll be even easier to do elimination with, right? Add together the left-hand sides, and I get 80. Add together the right-hand sides, I'll get 2y plus 0x. Of course, 0x, x was eliminated. Divide both sides by 2, and I get 40 equals y. Right, maybe you can just look at this and find x. If not, 50 equals 40 plus x. Subtract 40 from both sides, and I get 10 is x. Okay, now I've solved the model. I'm ready to answer the question. Remember, x was the speed of the current, y was the speed in still water. So my answer will be the current goes 10 miles per hour, the boat would go 40 miles per hour in still water. Does that make sense? Well, first of all, the boat is faster than the current, so it's going to be able to make some headway going upstream. That's good. These are both on about the same scale. They're both positive numbers. In that regard, they make sense. I don't really know anything about boat travel or currents, so I can't say if these are really reasonable speeds. I know it's faster than a walking pace, so that's pretty good. It's not some ridiculously huge speed. If I got 1,000 and 4,000, I would have big doubts. So in that regard, these seem reasonable.